okay. Little bit? Okay, so there's lots of people who don't really know anything about Camel, so I could be quite flexible today. What I thought I'd do is I'd give a brief overview of Camel, what Camel is, where it came from, what it does. I'll try to be quite quick for the people who know a little bit about Camel. I'll try not to get too much into the detail. And then I'll show some demos of how you can use Camel with Eclipse tooling. There's a really funky web console I can show you for working with Camel that I'd like to focus on mostly because it's cool. But by all means, stop at any point in time, put a hand up, ask a question. I can go into any detail you like at any point. So please jump in at any point. So I'll do a quick presentation on Camel and give an overview of what Camel is, and then we'll dive into the demos. Okay, so I'm kind of quite old. I've been doing IT for quite a while. And back in the day, we used to write applications. So there'd be like a standalone application in a silo, and you'd write a front end, and you'd write a database, and you'd be this little island, and that's all you did, and then you went home. And now we don't seem to write applications anymore, or we tend to write bits between applications, and we tend to bind applications together more than we actually write them. It seems over time we have more and more systems internally inside our organization, and with acquisitions and technology we keep having more and more things, and they all need to talk to each other. We need to take data from system A and put it in system B. We need to connect payroll and CRM and social media. It seems every year there's another technology, there's another protocol, there's another system, there's another thing to deal with. So this integration problem seems to be growing and growing. I certainly found in my IT life, as I've got older, I spend more time doing integration and less time writing a discrete service or application. So integration is becoming a harder and harder problem. Now, the first time you do any integration, like your boss says, please parse this file over FTP and read the data and put it in this database over here, or please consume these messages on MQ series, and when you get a message in, parse it might be XML, it might be JSON or whatever, can you post it to this web service over here? So there might be web services, there might be message queues, there might be files, there might be FTP, whatever. If there's just one of these, it's easy. You kind of pick the first technology like FTP, you do a Google search, how do you use FTP again, what's the Java library I should use, and then you figure out the Java code and everything's kind of cool, and then the next day your boss comes along and says, did I say FTP? I mean we've got a JCI content repository, or we've got an atom feed you need to parse, or now you need to pull a database, now we need to use Cassandra, now we need to use Hadoop, now we need to use something else. So the technology is always changing. You might write one piece of integration, it's all working really well, and then your company acquires another company, and you use MSMQ, and the new company uses MQ series, or you use MQ series, the new company uses Rabbit or AxoMQ. So over time, technology gets more and more varied, it gets more and more complicated, and integration soon looks like this. It's like a big ball of mud. It's a nightmare to understand, it's a nightmare to maintain, it's a nightmare to change. So there was a book written nearly 10 years ago now. How many people have heard of the Enterprise Integration Patterns book? Oh yeah, awesome. Good crowd, good crowd. So this is a really good book. I hope you've read certainly the first few pages of it. There's a lot of patterns in there. I think there's kind of like 5 big patterns that we all use all the time, and then some of the other ones are a bit more esoteric and take a little while to use. But the Enterprise Integration Patterns is a great way of explaining how to do integration. It gives you names for things like content-based router, content enricher, recipient list, routing slip. It gives you terms and patterns to talk about how to do integration. So what is Apache Camel? Here's a bunch of patterns, by the way. This is one of the sections out of the book. So the content-based router, message filter, recipient list, splitter, aggregator. Some of these, even if you've not read the book, you've probably got an idea of what they are. So Apache Camel is really just a simple Java implementation of the enterprise integration patterns. So it's just a Java library, it's not an app server, it's not a container, it's not a platform, it's not a cloud. It's just a Java library that implements the enterprise integration patterns. So it's really simple, it's really lightweight. Use it in any Java virtual machine, use it inside a standalone main, use it inside a Swing app if people still use Swing. Put it inside Tomcat, inside Jetty, inside JBoss, inside Java IDE, inside OSGI. You can use it any way you like. It's agnostic of dependency injection. You can use Spring if you want, you can use Juice, you can use CDI, you can use OSGI, you can use OSGI Blueprint, or you can just use Java code if you're not a dependency injection kind of person. So it's just a simple library to implement the enterprise integration patterns. So let's look at a pattern. This is a slightly dodgy example. This comes straight from the book. It's a kind of a slightly weird one. We have widgets and gadget quotes. I did every slide on widgets and gadget quotes. And these are messages These are conceptual messages. The Enterprise Integration Patterns book talks very much about messages and events. But don't think that that means it must be like a message-oriented in MQ series or ActiveMQ or something. These are conceptual messages. So these could be beans in a linked list, these could be rows in a database, these could be entries in an Atom feed or an RSS feed, these could be posts on a Twitter stream. These are just logical events or logical messages. Okay, so we have these messages coming in, we have widgets and gadgets, and we need to use the message filter to filter out the messages we don't want. Because if we sent a gadget quote to the downstream system, the system would explode because it doesn't understand what the gadget is. So we need to filter out the gadgets so only widgets pass through. Okay? So this is one of the Hello World Enterprise Integration Pattern. So let's look at how that looks in Camel. So apologies for the pointy brackets. I know that hurts some people's eyes. So this is XML with some pointy brackets thing going on. We have a Camel context at the top. XML namespace there, don't worry too much about the XML namespace. We've got the route. A route is a collection of steps. So there's usually one from, and there's usually at least one to, and then there's a pattern here, filter. So filter is the enterprise integration pattern. We're going from this URI, which is an ActiveMQ topic called quotes, and we're going to an MQ series on widget quotes, so the widget quotes queue. And we're going to filter with an XPath expression. So even if you've never done any Camel before, you can kind of look at that slide and you can kind of figure out what it means. Okay? What Camel very much tries to do is it's trying to be a declarative way of describing your integration. So it describes where you're going from and to. It uses a logical string to describe the endpoints. So you don't need to know Java APIs or weird protocols. So we use a simple URI to describe where we're going. We use this expression languages here for the filter. And we're using an XML tag in this case for the path. So it's kind of simple, it's declarative, it's kind of easy to read, especially if you look past the pointy brackets. How many people use Spring? Okay, quite a few. So if you ever use Spring, you have all that stuff at the top of an XML file, this stuff. So that's the bit you copy and paste whenever you're making a Spring XML. Okay? But the only difference is we've added one more schema. Spring requires that everything in the Spring XML has an XSD. It has XSD validation on my phone. So we have to put an XSD declaration. So that's the one extra line. Otherwise, that's just the normal Spring stuff. Now we've got the same Camel route inside the Spring XML. So now this is a real vanilla Spring XML. So if you're using Spring today on your application, you can just copy and paste this into your Spring XML, add the XSD, and now your app can just boot up as normal and you've got Camel inside your Spring. The only requirement is you add the Camel Spring jar to class path, and then you have Camel in Spring. So it's really, really easy for a Spring person just to use Camel immediately. Okay, let's look at it again. Notice we used XPath in the previous slide. We have a bunch of expression languages. This is a bit, we've got a few more than that now. When you're using XML a lot, people tend to use XPath as a way of navigating into the document and pulling out the thing you need. If somebody sends you an invoice as XML, which has line items, and each line item has a product, and each product has a code, you find yourself navigating this tree of stuff to find the data you need. Doing that in Java code can be kind of laborious. You end up writing reams and reams of code and just iterating down a tree. With XPath, you can just use this kind of path language with slashes. So if you're using XML, XPath and XQuery are nice expression languages to pull out a piece of data or look, is the amount of the order of over $1,000 or whatever. Doing those kind of expressions is much easier in XPath and XQuery. Camel supports a whole range of different expression languages. These two are not that Ordinal and Realm. They're kind of expression languages that are kind of like Java replacements. If ever you have a big domain modular, domain transfer object, or DTL. So you have a purchase order in Java code which has line items, each line item has a product, and each product has a code. And you need to navigate down a lot of object relationships. These are quite handy expression languages for doing that. Some people like Groovy in JavaScript, and Ruby in Python, and Bean Shell. And EL comes from, if you've done it in JSP and JSTL and JSF, that uses an expression language. Mainly because Java's kind of verbose. If you want to go from A to B to C to D to E in Java, you tend to have pages of code with your not nulls and your for eaches. These expression languages are just ways of kind of navigating through your data model nice and quick. One thing to remember with Camel though, if you don't like any of these expression languages, don't worry about it, just use Java code, everything's fine. These are just alternatives you can use if you wish to. Okay? So if you're using lots of XML, I'd recommend have a look at XPath if you've never tried it. It's a nice simple way of navigating around XML. If you like scripting languages, try one of these, but if not, just stick to Java code. Now we'll talk about endpoints. If you remember that far back, I think 2 slides ago, we used ActiveMQ and we used MQ series. Camel supports this slide's out there. I think we're at about 130 now. We've got lots and lots of components in Camel. So we can talk to things like AMQP and Atom and ActiveMQ, or CXF for web services, or FreeMarker, that's the template engine, or Jetty, which is a web server, JMS, JMX for managed beams, JPA is the standard for doing database access, Google App Engine, HDFS for the Hadoop file system, Hibernate, EJBs, I don't know what that is, dataset, Comic D for doing kind of WebSocket design, what else should I talk about? Or JCR if you're doing Java content repository stuff, or like CMS backend. JavaSpace if anybody uses those anymore. Okay, that's this slide, I'll talk about a few of those. LDAP, mail for email, if you need to read email, LDAP, POP3. Quick Fix if you need a fix engine. Smooks is a good transformation engine if you want to do message transformation. Xquery and XSLT, if you want to do a transformation using Xquery or XSLT, you can use that as an endpoint. So I can take a message, send it to an endpoint, which the URI is the template to execute. We have a bunch of endpoints which do templating. Xquery, XSLT, string template, velocity, FreeMarker, Scalate are all different kind of template engines. So sometimes you want to take a message and you want to send somebody an email, so you want to use a template that pulls out a few fields from the message and says, hello there, $username, how are you today on this date, $date. So template engines are pretty good endpoints to reformat things as text for emails and text messages and things. NetT does asynchronous HTTP, SMPP, Spring integration if anybody's chosen to use Spring integration on a team and you want to work with that team but you don't want to have to use Spring integration and stay in Camel, so we can use Spring integration endpoints from inside Camel. And there's basically there's lots of templates, lots of endpoints. There's pretty much a component of an endpoint for almost every technology that is popular. So it's really easy to write your own endpoint and component. So if ever you have to talk to something and there's not a component already, don't get scared, have a go at writing your own component, it's pretty simple. One thing I'll just mention on this slide, Nina, there's an Apache project called Nina, which is a library for doing TCP, UDP, multicast kind of networky stuff. Now sometimes when you're doing integration work, there's this ancient system that sits under somebody's desk that's been around for like 30 years, that was written in COBOL or C or something. And the only way of talking to it is over a socket with some weirdy protocol. If ever you have to do one of those things, you have to talk over sockets or UDP to something, have a look at Mina. So Mina is a library that you can write, they call it a codec. So you can write a way of streaming the message on and off a stream, like an input stream. If you can write a codec that understands the messages, Mina does all of the networking stuff for you, connecting to the network, keep alive and all that kind of stuff. And then the Apache Mina, the Mina Camel component just wraps your codec into a Camel endpoint, so you can just send messages in and out, and it hides all of the networking. So if ever you need to do really crusty integration of the sockets and stuff, have a look at Mina. But the basic thing to take from this is we have components for pretty much everything. JDBC, JPA, JMS, MQP, files, FTP, Twitter, pretty much all the social media endpoints are just about done now. And gradually the endpoints are growing and growing and growing. Camel has 3 concepts that I'll briefly mention. They're all kind of related. We have URIs. If you remember from the Camel route, we used URIs. Let me pop back. There we go. We use URIs in Camel routes, which are strings. So we use a string representation of endpoints, rather like the internet with HTTP : / whatever, or mail to : or file : or FTP : So we're used to this URI syntax on the internet. We use the same kind of syntax in Camel, The difference is we work with any scheme, so we can use different schemes up front. So rather than just HTTP and FTP, we can talk to MQ series and ActiveMQ and JPA, JVC, and yada. So Camel uses these URIs as a way of referring to endpoints. Now an endpoint in Camel is just a bean, which is capable of consuming or sending messages. Really. And anything can be an endpoint, it's just a bean. You can write your own bean, which is an endpoint, pretty simply. You just have to implement two methods, pretty much. Create producer, create consumer. So it's pretty simple stuff. What Camel does is, Camel has three things, okay? It's got URIs, which are the strings, and it's got a thing called a component, which is a terrible name, it's very overused. In a Camel sense, a Camel component is just a thing which you give it a string and it makes an endpoint bean. Okay. So we have the endpoint beans, which are the things which send and receive messages. We have the component in the middle, and it's the factory of endpoints, and then we have the endpoint URIs. It sounds a bit complicated. The reason we do it this way is Camel really wants to do convention over configuration. So imagine you're doing lots of messaging. Say you work in an investment bank and you've got lots of MQ series, and you've got lots of TIBCO EMS, and you've got lots of active MQs. You've got 3 message brokers, and you spend your time working with these different message brokers all day. So you might go from QA or message broker 1 to QC or message broker 2. Now you could, if you really wanted, every endpoint could be a bean, and you could use JNDI and put every endpoint in JNDI, or you could use Spring or Juice or whatever and configure every bean by hand if you want, and that's cool. What we try to do with Camel is try and let you configure the components once. Configure how to talk to MQ series, how to talk to TIBCO EMS, how to talk to ActiveMQ. Configure the components to talk to the message broker. And then the endpoints then just become a name. So you don't have to configure every endpoint, basically. So the component acts as a central point of configuration. In this example, we can configure the ActiveMQ component. We can say the host name and the password and the login and password and like it. For MQ series, we can say what the domain manager is and the queue and the yada. We can configure these two schemes, and then anything after the colon, they're just names. And at runtime, the component will look up the right queue or topic automatically. If you've ever done any Java EE with JMS, it always recommends you put every queue and topic in JNDI, which is just hideous. Like a queue and topic is just a name, right? It's just a name we use to communicate. Rather like an email address or a URI in a website. Having to put all those strings into a registry which has a separate name, and then you put this level of indirection just to get to the name, it's kind of hideous. So what you really want to do is just refer to endpoints as just names, they're just strings, and we communicate on those names. So the component abstracts the mapping between the name and the physical device. Now, getting wacky for a second, if you really want, you can make your own component to do anything. So if you want to use Camel and you want to do all these integration routes, if you wanted, you could use logical business names here. You could use the scheme could be the name of a group, so it could be accounting : purchase order input, and sales : commission. So you could use logical business URIs. All you've got to do then is write a component for each scheme. That given the string you give it, it figures out what the real physical endpoint could be. So some people have, in the past, some investment banks have built these really big complicated systems that have like a big meta model of all the endpoints everywhere. So they've got a big database of which teams, which group and team and function, how does that map to a physical queue and MQ series or whatever. If you want to do wacky stuff like that, you can do it yourself by just implementing your own component. It's really simple. So another example could be, you could write a JNDI component that you do JNDI : cheese, and it takes a string and looks up in JNDI to find the queue or topic. So you can do all kinds of wacky levels of indirection if you want. Enough of all the wackiness. The simple thing is, we can just refer to endpoints by name, and if you're using, say, ActiveMQ or MQ series, you just use MQ series : and then the name of the queue, and that's really simple. Okay, so to recap, we have the patterns, and we have a blob of XML with the patterns in. We have from and to with URIs, nice and simple. We have expression languages if you wish to use them. We can always use Java code if not. And that's kind of mostly Camel. It's patterns, it's expression language, and it's endpoints. That's kind of mostly it. So for those people who don't like pointy brackets, here's a Java version. So this is a Java version of the same Camel route. One of the goals we had with Camel was we wanted to be able to take any enterprise integration pattern and write it in one line of Java code. And this slide is kind of proof of that. Technically, it's 3 lines on the slide, but there's only one semicolon. Okay, it's one. I put it on 3 lines just to fit on the slide and be a large font. If I did a smaller font, it would fit on one slide of program. But the other thing that's interesting is you can kind of read this and it's still readable. You can say from ITMQ, filter with XPath, and then to MQ series. So even if you had never used Camel before, you can look at this line of code and go, yeah, I can kind of figure out what's going on. You might understand how it works. You might understand how the MQ series part works or how the ITMQ bit works, but you don't understand what it's doing. And then somebody came along to you and said, can you please get rid of this MQ series crap? It's expensive and it's slow and you need a sysadmin to use it. Can we just use more ActiveMQ, please? Because that's cool and that's open source. So all you've got to do is change that text string from MQ series to ActiveMQ and you can now switch middleware. Or if somebody says, I don't want to use messaging at all, I want to use a file system. So you do, okay, file colon widget quotes. You've now switched from JMS to file system by changing one string. So one of the big reasons for these URIs is Camel is middleware agnostic. You can switch from files to FTP to in-memory libs to MQ series to AMQP to whatever by just changing a string. It's really simple. So we're hiding the middleware and making things agnostic. So here's how you really use Camel in real Java code. So you do a package statement usually. You have to import this class route builder. If you add Camel call to your class path in your IDE and you write a class and you extend route builder, your IDE, hopefully, well, if you use an IDE rather than a text editor, it will automatically generate the configure method because that's abstracting the base class. Okay? So you extend route builder. You have to implement this abstract base class method. In the method, you then have access to this DSL, domain specific language, or Fluent API for creating elements. So as soon as you're inside your IDE in the configure method, you can start typing from, and all of the Camel DSL appears. So you get syntax highlighting, completion in your IDE, and so that's how you write a route builder in Java. If there's any Scala people in the house, this is a Scala version. I won't focus too much on Scala, but there's a Scala DSL. We have a DSL for XML, for Scala. We have an experimental one for Kotlin. There's obviously Java, there's Groovy, and there's Ruby so far. It's actually quite easy to write new DSLs as well if there's a particular programming language you like or domain-specific language. Okay, so imagine you've got these route builders. The route builder by itself doesn't do anything until you activate the route builder or install the route builder somewhere. If you're using Spring, you can use this, which will then do a package scan. So it will scan your class path for all classes in that package, which you put on route builder, and it will then instantiate the route builder into the Camel context. So that's one quick way of booting up your code of using Spring. If you're not a Spring person and you just want to do it, if you want to kind of go down to the bare metal and write real Java code again for stuff, this is how you do it in Java code. So you create a Camel context. A Camel context is a bit like a Spring application context. It's kind of like the thing that you put everything inside. Typically, you only really need one Camel context for your app. Some people use different Camel contexts for different kind of groups of things, but really, it's not like a Spring application context. You tend to just use one for your app. It's no big deal if you use a few, but you usually just use one of them. Add all your routes to it. So here I'm adding my route builder, and then you call start. And whenever you like, you call stop. Okay, so it's really simple to boot up, even if you don't use dependency injection and you don't use Spring or anything like that. Okay, here's a quick screenshot of what it looks like in an IDE. This is IntelliJ, which is the best one. You should all use IntelliJ. But this works in NetBeans and Eclipse and various other things too. Notice once you type from A and you do dot for E, all the patterns appear in method completion and all the varieties of parameters you pass in. If ever you can't quite remember the name of a pattern, you know, like it's R something. Was it recipient list or routing slip? I can't quite remember. Just hit R and do whatever your splat key press is to get the completion list to appear. And just scroll through. Notice if you hover over any of these, the documentation tab can pop up, which has the Java doc for each pattern, which kind of tries to describe what the pattern is. If that doesn't convince you, or if that's not enough documentation, there's also a link here which then links to the Apache Camel website, where every pattern has a web page with example code, reasons for using it, reasons why you might not use it. And if ever you don't believe what the Camel website's telling you, there's a link to the Bible, the Enterprise Integration Patterns website, so you can see the real Bible entry of what the pattern's for and why you'd use it. So even if you're using the Java code, it's very easy to look at some Camel that's maybe a colleague has written, and just use your IDE to look at the Java doc to see if there's a pattern you've never used before or something. Just use the normal IDE Java doc stuff to find out details about the pattern and navigate from that to the docs. So it's really easy to understand patterns that you're unaware of. We have some IDE completion in the XML version. It's a bit crap compared to the Java one because the Camel project could generate the XSD for Camel. Right? So the XML language has an XSD. So if you have an editor which is XSD aware, you'll get completion, which is okay. The only downside is the completion has no documentation. So you can't link in the XML editor from the tags to the documentation. But I'll show you how you can do that in Eclipse in a minute. So whether you use Eclipse, whether you use XML or whether you use Java, you get full type completion in your editor. Right? You don't really have to use some special tool. Okay, I've got a quick breath. So to summarize, enterprise integration patterns, they're cool, they help us describe and talk and communicate about integration, so patterns are good. Camel implements all the EAP patterns and a few other ones. It's mostly about routing things around and transforming messages and that kind of thing. We have these DSLs, domain-specific languages in Java, and the main ones are Java and XML, to be honest. We use endpoints and URIs to talk to things. So we can talk to anything, any file, any database, any table, any technology, any API. We can talk to it with a little string URI, which is nice and simple. The patterns tend to use predicates and expressions all the time, which you can use Java code, you can use a Java method for if you wish, or you can use expression languages. And there's lots and lots of components. There is a test kit, which I can maybe show you at some point this evening, but I don't really have time right now, but we can maybe talk about it later. There's a test kit. One of the things that starts getting tricky when you do integration, let me give you a scenario. Imagine you're doing integration testing and you want to test, you need to shovel some data into some system. You might have a bunch of sample messages you want to shove into a training system. So you want to put some trades in a training system, and then you want to check the settlement messages that come out the back of it. So you might talk to a training system, and then the training system might then talk to some settlement engine or some payment engine or something. So once you've got a couple of systems and they're all talking to each other over some technology, say message queues or files or something, when you're testing these things, you often want to pump messages in one place and then listen somewhere else and see what happens. The other problem is you tend to have lots of asynchrony going on. Like you might write files to a directory, but the order in which they process could be random, or you might write to a queue, but there might be concurrent consumers on the queue, so the order can get out of whack. So ordering can go a bit weird, and then things are asynchronous, so you can't often just sit there and block and say, I'll send 20 messages in, and I'll block. So there's the asynchrony issue and the timing issue, and there's the physical issue of how do I send all these messages into all these different systems. Well, Camel can do almost all that for you anyways. Camel can talk to all these different systems, it can send messages to anything, it can consume messages from anything. So we've got a test kit in Camel, which is initially written to test Camel, but it can actually test kind of anything. Anything you can send messages to, write messages to a database, pull a database, write messages to the file system, read files from the file system, write messages to a queue, consume messages from the queue, any permutation of technologies that you can read or write, invoke a web service with web services, with REST, yada yada yada. Pretty much all systems now have some kind of interface to them in some sense. We can use the Camel test kit to send test messages in, consume from outputs of systems, and assert that the right number of messages arrive, messages have the right content inside them, and so on and so forth. When I talk about this with people, people often say, I can't possibly do integration testing in my real systems because the messages that come out of the back end, they have like timestamps in them, and they have host names and IP addresses, and all these kind of crappy headers that I can't compare against. Well, Camel can do transformation too, so you just filter those out. Just filter out some strings from the message that you can compare against, and do that for testing. As a for instance, let's say I want to test that trading system. Fire some messages in, then I want to check, let's say I fire in a Microsoft and a Google and an IBM trade, and I want to check when the payments come out. So I subscribe to where the payments are coming out, and there might be this huge blob of JSON or XML or whatever it is. Well, I can't really do an exact comparison on that because it's a huge complicated structure, but I could use Camel to transform the payload to pull out a couple of strings. Pull out with an XPath expression the trade, the currency maybe and the instrument code. Turn it into a string, and then I can just in my unit test say, I assert that you get Google, then Microsoft, then IBM, in any order. You never have a unit test case for testing your system. And it can survive all this extra crap being written to the message. So the Camel test kit is really, really awesome, but I'll maybe go into that later when we've got beers going and maybe pizza's here. Okay, I've almost done on the Camel overview. I'm going to get to the demos soon because they're much more cool and interesting. I'll just talk briefly about beans. Camel focuses very much on trying to write enterprise integration patterns in a declarative way. Part of the reason we want to do that is so that your team members can understand what you mean. You can describe what you're trying to do, but you describe what you're trying to do, not how. Then as technology changes, the diagram and the understanding can stay the same. Middleware can come and go, and you can switch from middleware to middleware, but you can still understand what you meant when you wrote the Camel route. Plus, sometimes we forget what we do. You write some code, 6 months goes by, you can't remember, what was it I did again? It was 50 pages of Java code. What did I mean by that 50 pages of Java code? With Camel, we're trying to focus on the meaning, so it's very easy to understand what the integration does, so you can change it. However, not everything is in the Camel DSL. Sometimes you have to write Java code, I'm afraid. So I'd just like to talk about how you write Java code, how do you put Java code into Camel. Camel can't do everything, okay? Camel is awesome, it's really awesome. It can do everything. So Camel doesn't have a DSL for currency conversion, or calculating the business days in a calendar based on a location, or it can do stuff like that. There's times when you have to use a service, so you have to use some Java code to do enrichment or whatever. So here's one way of doing it. We consume from an ActiveMQ queue, we're going to send to another ActiveMQ queue, and in the middle we're going to call a bean. We're just going to invoke a Java bean. We're going to look up a bean by name, my bean name, and we're going to call some method on it. So here we're going to use a Java bean with a function, and we're going to process messages with that Java bean. Okay? Let me show you what the bean looks like. There's a bean, awesome. So basically just a class. There's no middleware APIs, there's no JMS or anything. It's a bean, it's got a method. It takes a payload, this is the name, and it returns a value. I've used strings here, don't think it has to be strings, it can be any types. I've just used strings here for simplicity. The nice thing about this bean is there's no middleware here. We recommend, by the way, try to never use middleware in your application logic. Because it means I now have some logic here. I can write a JUnit test case, or test ng or whatever. I can write a test case to test this without any middleware. So I can test my code really easily. I don't have to boot up app servers and message brokers and all this kind of stuff. I can just test this really quickly in a unit test case and know it works. So Camel is going to look this bean up in a registry, in JDI, in Spring, in Juice, in CDI, in Blueprint, whatever you use as a registry or dependency injection. It's going to look up that bean and invoke it. Okay, here's a slightly different way of doing the same thing. Because quite a lot of the time, you just want to consume from an endpoint, process the payload with some Java code, and send the result. So if you like the simple version of a Camel route where you go from bean to, if all you want to do is consume from something, process the message with a bean, and then send the result out, you don't really need to do the whole domain specific language Camel route thing. You can just use a bean with a method and just add @consume. @consume is in the Camel call jar. And now you have something that looks a little bit like a message of a bean. Has anybody done a message of a bean before in Java EE? Okay. Now you've seen this slide, please never do that again, and please use this instead. Okay, I'll tell you why. I think there's at least 3 reasons, there might be 4, but there's at least 3 reasons why you should use this instead. Okay, if you use a message of a bean, it gives you a javax.jms.message. Okay, so the parameter is onMessage, and the parameter is, this is a type JMS message, which is fine. I like JMS and everything. The problem with JMS though is, you can have lots of different kinds of message. the javax.jms.message type, there's no way of getting a payload on that interface. So you have to say, I know you're a message. Are you an object message? So in here I have to say, if instance of object message, then cast it, create a new variable, cast it to an object message. Then you call object message.getObject. And now we have a java.lang.object of the payload. Now you've got the payload as a Java lang object, then you need to say, are you an instance of, I don't know, a string or something? And you gradually have this lines and lines of code just to get the damn thing out of the message. It might not be an object message, it could be a text message. So, okay, so if it's not an object message, is it a text message? Okay, if you're a text message, cast to a text message. Now you call get, is it get string, get text? I can't remember. Anyway, you call a different method, it's not get object. You call a different method, and then, but it could be a bytes message. So if it's a bytes message, you kind of got this crappy API to pull out a byte array. And then it could be a stream message, and probably nobody knows how to use those anymore anyways. So it's basically, you've got a lot of crappy code you have to put here just to get the damn object out. Okay, so that's the first reason why message-driven beans don't suck. The second reason they suck is message-driven beans only really work with JMS. We're using all of Camel's URIs here, so we can use this to consume rows from database. We can pull database tables, files, FTP. We can pull Atom feeds, Twitter feeds, Facebook profile pages. We can use Google App Engine, Hadoop, HDFS. Pretty much any technology that's of any popularity we can use here. So we can use the same coding mechanism. It's like a message-driven bean, but we can use any technology here. And more importantly, we can switch from JMS to Java Spaces to a file system whenever we like by just changing its string. Okay, so that's the second reason. It's technology agnostic. Then the third reason is, if you're using message-driven beans, there isn't an easy way of sending a reply. You would have thought there should be, but you're given a message, and then if you need to send it somewhere, you have to create a connection factory, then a connection, then a session, then a message producer, then you send it. Then you close all the objects down again. There are libraries you can use to abstract this, like Spring's JMS template, but it's kind of crappy. Here you just return an object. You return an object, the return value is the payload you send back. So if you're using a transport, or a quick aside, some middleware is one way, in only, to use WSDL terms. Some middleware is request reply. If you send an email to somebody and there's a reply to header on the email, you can send a reply back. If you're using JMS, there's a header called JMS reply to. If somebody sends you a JMS message with JMS reply to, then you know how to reply back by sending a message to that destination that's on the message header. Camel uses the same thing. If you return a value here, the component or the endpoint, if that is capable of sending replies back, the endpoint sends a reply back. So if this was email, POP3, we could send an email back to the person who sent us the email. If this was JMS, and there's a JMS reply to header on here, under the covers, Camel will send a message to the destination, which is on the message header, JMS reply to. And so the sort of HTTP is easier. You tend to post to HTTP and you send back the response over the same socket. So HTTP is an easy one. But basically, whatever the technology is here, if there's a way of sending a reply, Camel will use it. So those are the three big things. Okay, so you don't have to unpick a JMS message. It can work with any technology, not just JMS. And you can send back replies, which is kind of handy. I guess another thing is you hide all the middleware. There's no JMS API at all. Okay. So I guess that's a fourth thing. There's a fifth, I guess, too. Okay, so still, never use message-driven beans ever again. There's a fifth thing. You can choose whatever payload you wish. You can choose the type of your parameter here. I've used string here, but you could use an XML DOM. You could use a DTO. You could use a byte array, a byte buffer, a reader, a writer, whatever. You can use any Java API for the payload. And Camel has a type conversion thing under the covers that does the conversion for you. So you get automatic conversion between different types. Slight tangent, we created a project called Service Mix many years ago, which is based on a standard called JBI, which kind of Camel has kind of replaced, to be fair. People used to use lots of JBI, and then people start to use Camel, and now people tend to use Camel instead of JBI. But anyways, JBI tried to do integration using XML. They thought, well, if we do everything with XML, it'll be all easy, because XML is easy, right? So then people would have all these components that could consume or emit XML, and then you'd say, well, okay, what API do you want the XML as? Do you want it as a, just using the JDK here, there's a stream, there's an input stream, there's a reader, there's a string, there's a byte array, there's a byte buffer, there's W3C DOM, there's tracks, sources, there's stacks and sacks, and there's probably a few more, and that's just in a JDK. And then outside the JDK paper, we use Xstream, XML beans, JAX-B, the list is endless. So even in the XML world, there's a zillion different APIs. So if somebody in your team is sending you XML and they're using DOM, W3C DOM, somebody else might want to use ZOM or JDOM or DOM4J or JAX-B, or you're using JAX-B but somebody else is not using JAX-B, they're using Jackson or whatever. So even if you're using an interchangeable data format like XML or JSON, figuring out an API to use that everybody can agree on is a nightmare. So Camel under the covers just transforms things for you, which is really, really nice. So yeah, don't use message-driven pings, just use Camel. Here's another example where sometimes you don't just want the payload of a message, but you want some headers for the message. So you might be consuming something from HTTP and you want a HTTP header, or you might be using JMS and you want a JMS header. So you want to get some of the middleware stuff, but you don't necessarily want to go with a whole JMS API or serverless spec or something. So here's a way we can use annotations on the parameters of this function, and Camel will inject the right values. So here we're using an XPath expression on the payload. So rather than giving you a DOM object, which you then have to walk through the DOM object, and then you have to figure out, oh, how do I do XPath again with W3C DOM? I can't remember. I know there's an API somewhere. And then if you're going to use an XPath expression, how do I cache the XPath expression so I don't have to parse them for every message and all that kind of stuff? So rather than figure out how to do XPath properly and efficiently, just do at XPath. The XPath expression goes here and injects the result value into a parameter. So if you want to do an XPath expression on the payload of the message, or XQuery, or Groovy, or JavaScript, or whatever, you can use expression languages, or you can just plot headers. Here we're pulling out the JMS correlation ID. And again, we can use any type. We can use Boolean, long, float, double, DTOs, and whatever. So we can do all the type conversion and all the extraction from the message for you. So you just write your Java code for your business logic, which has a type-safe API, which you can then test easily from outside the middleware. Okay. And I'll show you the converse. This is how you do the other way. How do we send a message from inside Camel? So we're in some bean. We might be in a servlet or an EJB or a JAX-RS bean or something. We're in some Java code somewhere, and we suddenly realize we want to send something to some endpoint. How do we do that? So Camel has a thing called a producer template. If you're a Spring person, they tend to use the postfix of template and things like transaction template, JMS template, JDBC template. So we went with the same naming convention, producer template. A producer template is a template for producing things. And the producer template is a Java interface in the Camel core Java. And it's got a whole bunch of helper methods for sending messages to endpoints. There's lots and lots of these messages with different parameters and things like that. What you can do is you can have a producer template that has a default URI. So if I always want to send to that one endpoint, I can just say send body and pass in the payload. And the payload could be a DOM, it could be a DTO, it could be a bean, it could be some bytes, it could be a string. Send any payload here, and then Camel will just kind of deal with it. There are mobility versions of this where you can pass in the URI as a string, so you can dynamically decide which endpoint you want to send it to first. There's also a helper method for doing request reply, so you can say, send the message here, get the reply back, and when the reply comes in, can you invoke this piece of code, please? So there's a whole plethora of overloads of data on this method. If you just do producer dot in your IDE and look at the methods, there's quite a few. So it's a nice, easy way of invoking any endpoint in one line of code. How many people have used a JMS API before? Okay, it's kind of a beast, isn't it? I've worked with it a lot. You've got a connection factory and a connection and the session and the producer and consumer, and you've got to decide how many connections, how many sessions, how many producers and consumers. And you've got to pool your producers in these sessions, really, and then consumers, you've got to have a consumer pool, and all that stuff is just hideous, really. Here, it's one line of code, you send the message, and it just kind of works. So it does the right thing internally with the right fluid. So it's a nice, easy way of just hiding all the middleware. Now, I did say a few slides ago we should hide middleware APIs from that code, and the last slide had producer template, which is a Camel API. So here's how we can hide the Camel API. So if we want to hide all the APIs we're sending, we can write our own little business level listening interface. So say hello is my function, my interface, and it's going to take, I'm using strings here, but it could be any types. Now at create bean, I'm going to do add produce to inject the producer, but here I'm going to use my interface that I've just made up. So there's no Camel API here. There's Camel annotations, but they're not really APIs. Now I can just invoke that method as normal, but under the covers it's going to inject a dynamic proxy, which when you call say hello, it's going to send a message to this queue. So it's a way of hiding Camel completely behind the type-safe API. Now the nice thing is now you own that API, you're in charge, you're in control. You can instantiate that API any way you like and use it in test cases. So you can create this bean, inject this, and test it yourself without using Camel if you wish. If ever, God forbid, you decide not to use Camel, you could just rip the Camel out. Not that you ever should. But you could if you wish. Final plug, and I don't get any commission for this, and I really should because I've plugged these two books a lot. But there's Camel in Action and there's ActiveMQ in Action. They're both really good books. I'm lucky enough to work with all the authors apart from Bruce, he doesn't know what it is anymore. But you can't read it here. Klaus and John, who wrote this book, work with us at Red Hat. And so does Rob and Dan. So we're all Red Hatters who wrote almost all of these books. I didn't write any of these books, but they're both very good. The Camel in Action one is very good at going through like deep diving real world examples of how to deal with error handling and transactions and dead letter queues and all the thorny kind of things you're going to have to figure out before you go into production. I've glossed over lots of detail in this talk. But definitely if you're interested in Camel, definitely get that book. If you're interested in ActiveMQ, definitely get the ActiveMQ book. Actually, they're both really good books. Okay, right, it's demo time. How many time? Oh, okay. I talked a bit too much. Right, enough boring talk, let's do a demo. Let me switch my workspace to a nice clean workspace. So what I'm going to demo first of all is something called Fuse IDE, or the Fuse Eclipse plugins. I should explain what all that means. So I used to work for a company called Fuse Source that got acquired by Red Hat. So now I'm part of the JBoss team at Red Hat. Okay. And now our product was called Fuse, well it still is called Fuse. Although it's now called JBoss Fuse, but anyways. So our product is Fuse, and all Fuse is really is our distribution of a bunch of Apache projects. So ActiveMQ, Camel, Service Mix, Carafe, and CXF. ActiveMQ is a message broker, Camel is this integration framework thing, Carafe is an OSGI container, kind of like a lightweight app sort of thing, and CXF is a web services framework. The two we're to focus on is ActiveMQ for messaging, Camel for integration. Okay. So Fuse was our name for all of that stuff. So we have a set of Eclipse tooling, Eclipse plugins from Fuse. In other words, Camel and ActiveMQ mostly. So I'm just going to do a quick demo of how, if you want to play around with Camel, how do you take this kind of theory from the slides before, how do you actually do some Camel? So I want to show you how really easy it is to do some Camel. In a couple of minutes, you go from nothing to doing something vaguely useful, and then you can play. So rather than reading reams and reams of books and boring things like that, you can just kind of get your hands dirty and play with it. I'm just going to do a very quick demo. Anyway, so it's all Fuse IDE, it's just Eclipse plus some plugins, right? So I'm going to create a new project. I'm in the Project Explorer, I'm in the Java perspective of the Project Explorer. I'm going to right click, I'm going to say New, and then there's a Fuse project. Isn't that a Fuse project? Click Fuse project. Always click Next on this one. It basically says, do you want to put this project in a different place to where all your other projects are? And I never do. So just ignore the first page. Now here's a list of loads of example projects you can create. There's quite a long list. So if you want to do some, I don't know, rules for doing rule engine stuff, or you want to do some blueprint for doing OSGI blueprint, or you want to do some Scala or some, there's all sorts of stuff in here. CXF for web services. You could do contract first or code first, and so on and so forth. In this example, I'm going to pick the first one in the list, which is, I'd recommend starting with this one. This uses Camel and ActiveMQ together in the same project. So I'm going to click Finish. You can type in group ID and artifact ID and all that kind of crap if you want. I'm just going to hit Finish. And this should, touch wood, create a project in my Eclipse workspace. I'll just wait for it. The first time you do this, it might download the internet a little bit, but most of it should be inside Eclipse. Now I'll expand it. So now I've got a regular Eclipse project. I've got a POM XML, if you want to look at that. There's a POM, there's a README, there's source directories and all that kind of stuff, and config files. There's a little directory called Camel Contexts. And that's a little folder of all the Camel files you have in the project. And there's just one here. If I double click on it, that opens the Camel editor. So we have a design time editor for all the Camel routes. Okay, let me maximize this a bit. So each Camel route has its own panel on the, has its own canvas. In this example, we have two Camel routes. So you see the tree on the right. This is the outline view on the right. You see where the cursor is? The thing on the right, you can see we've got two Camel routes. And we can switch between the two Camel routes by just clicking in the outline view, or we can switch between the Camel routes using this routes menu. So we have two separate Camel routes. This one's a content-based router, so we go from this queue with a content-based router to this directory or this directory. I'll demo very quickly the designer. It's just like all the designers. It's a drag and drop and connect kind of thing. It's no big deal. What I will just mention is when you click, if I click on the Properties tab, as you click on nodes on the tree, on the canvas, sorry, you get all the details here of each pattern or endpoint. So different patterns have different configuration values. So the Property tab lets you change like the URI of the endpoint or the properties of the, in this case we're doing an XPath filter, we're using XPath, and there's the XPath expression and so on and so forth. So as you click on the canvas, you can edit all of the various properties. Enough of all that. I'm not going to focus on the editor because it's kind of dull. I'm going to show you how you run things, which is much more interesting. So I'm going to right click, then do run as, and it's this thing, run as local camel context. Now we should always run the tests, so really you should always run the tests and click that one, but I'm going to be naughty, I'm going to click without tests. Because life's too short, we just need to get stuff done, okay, so I'm not going to do the test. And sorry, that was quick, I meant to show you the whole thing. So what that should do then is download all the stuff from Maven, compile any Java code in the project, boot up a JVM, and it's got the camel running inside. Okay, so that's running. Total of 2 routes started. Okay, so that's not terribly impressive yet. We've just ran some stuff and we've got stuff in the console. Let's switch. There's a new perspective called the Fuse integration perspective. Now this is way more fun, really, or interesting. So basically one of the aims of Camel was to help people understand, well, do integration easily, but not just physically doing the integration, understanding what the integration is doing, so that over time you can change the integration. And team members come and go on different projects or different companies or groups. Technologies come and go. Are we moving from file system to MQ series now? Are we moving from MQ series? We've seen the light, we're getting rid of MQ series. We're going with ActiveMQ instead, or whatever. Middleware changes. We want to make it easy for people to understand what they're doing and migrate integrations from technology to technology. So as well as making it easy to code the integration, we want to make it easy so you can understand the integration. So the Fuse integration perspective, it has a tab called JMX Explorer. I don't know if you can read that text. This is JMX Explorer. This is basically like if you use Visual VM or JConsole to connect to a JVM. We're running a JVM on my laptop right now, and we're going to connect. We've discovered all the Java processes that we're running on my laptop. It's found the local camel context that we booted up. So this is all remote process stuff, right? This will work with any container app server thing that's on your machine. We can connect to any JVM that has JMX enabled. If we double click, it connects it over JMX. So this is inter-process communication, right? This would work if you're using Tomcat, Jetty, JBoss, Carafe, Service Mix, Fuse ASB, whatever, or a standalone name, right? So long as there's JMX enabled, we can connect to it. When we look inside the JVM, we can use the MB instead of JMX to detect, there's some camel in there. Not only that, we can find all the camel contexts that are running, because you might have lots of these. And for each camel context, we can look at all of the routes that are running. So we can visualize each route that's running, and we can show all the metrics of all the routes. So we can just connect to a JVM and just look at it and say, that JVM is running 10 camel routes. Let's look at the camel routes. Let's see what they're doing. This camel route isn't processing any messages. Why is it not processing? Well, where's it going from? Oh, it's going from this queue. Why is it nothing on the queue? So just from just looking at a JVM, we can deduce what is it doing, what technologies it's using. This camel context, what endpoints does it use? Oh, it uses one queue and a few directories. Well, okay, let me browse the directories then. So instantly, without knowing anything about the code and how it was written, and what technology it uses, and whether it uses the Java DSL or the Scala DSL or the XML DSL. Sod how the thing was written, we can just connect a runtime to any Java process with Camel inside, and we can visualize it. We can see what it's doing, we can see how it's doing it. You can even wackily edit the root at runtime, which is quite wacky. I don't recommend this in production, by the way, but you can just right-click and say edit. It then downloads the XML model of the route, opens the editor, lets you edit and lets you save back at runtime, which is kind of wacky shit, but don't do that in production. But it's for debugging, it's pretty handy. Or if you're using Camel to replay messages in integration testing or whatever, that's pretty handy. But another thing I want to show you is we can start to look inside. A common thing people hit, they start using Camel and go, oh, that's really awesome, I don't have to use the JMS API anymore, or this AMQP thing. I can just hide all the middleware and I can just get stuff done, this is awesome. People start playing with Camel and that's all cool, and then they'll get something working and it's fine, and then somebody might add an XML namespace or something somewhere, and all of a sudden nothing works, and everything's just completely broken. And people are often like, well, where do I set a breakpoint? I've just written an XML file, how do I debug that? So one of the main aims of this tool is so you can see and understand what's running. And more than that, we have tracing. Let me show you tracing. So imagine this is just some code that you didn't even write. Someone in your team is running and it's not working. So you're in test mode now. I'm testing it and it's not working. It's like, oh, okay. This route here, it goes from this ActiveMQ queue. It's got a content-based route and it goes here or here. Okay, well, let's try and figure out why it's not working. Right-click, click Start Tracing. Okay. There's a slight bug where it decides to close the tree now, which it shouldn't really do, so I'm just going to quickly open that as if nothing ever happened. Okay, so we've enabled tracing. Okay, that's all cool. We've got this messages view thing here. Actually, let me just, yeah, that's cool. We've got a message view tab here. Now, we can, let me just show you, this is ActiveMQ tooling now. I can just show you, we can create new queues. We've only got one queue here. I can create a new queue, let's call it beer. So we've got a new queue called beer, and if I browse, there's no messages on it, but I can just go in my file system, oh, there's a few messages. And I can click and drag, and I'm still dragging, and I'm going to drop, I've dropped. And now if I click, I'm browsing, this is a JMS queue here, so I'm browsing the JMS queue, and now I can see two messages on the JMS queue. Let me insert this a bit. So I've put two messages from my file system onto a message queue there, which is a drag and drop, right, which is cool. What's even cooler is this works on any Camel endpoint. So you might not have tooling for FTP or File or Jabber or Hadoop or Google App Engine or Cassandra or whatever it is that you're using. You can do drag and drop from any endpoint to any endpoint in Camel. Right? So you can drag and drop to a database, to a file system, to FTP, and yada. Okay. So what I'm going to do now is I'm going to not drag and drop to a message queue. I'm going to drag and drop to this. Well, actually I am, but I'm going to drag and drop to this Camel endpoint just to show you what's with Camel 2. So I'm going to take one message, I'm going to click and drag, almost time to stop and have a pizza. I've clicked, and I've dragged and dropped on the queue. There's no messages on the queue, because we're consuming from the queue, and Camel's, as soon as we drop a message on, Camel's consuming all the messages. So there's no messages anymore on that queue, because I've dropped it and it's gone already. But if I click on the route, I now have 3 messages, which is kind of wacky. I've got 3 messages. So I send 1, I get 3. What the route tracing is doing is it's keeping a copy of every message as it goes from every step through the route. So if I click on the first message, you see that's where it starts. And if I scroll down with the cursor keys, that's the next point. Then it goes here. So I know that that XPath expression was true. Okay? And at any point along the route, I can see all the headers and the payloads. So if the different steps are adding headers and transforming payloads, I can see where does the body get garbled, or where does the header disappear. So you can just step through your routes, see what it's doing, see where the problem occurs. If I drag and drop this other message, click, drag, drop, drop, and now click back on the route, I've now got 6 because 2 messages have been round 3 hops each. So if I click, this one goes there, and then this one goes there. Okay, so I can see different messages go through in different ways. And I can do things like I can just edit the message because it's just a bomb XML, and I can mess with it and try it again and see what happens. So you can kind of play with Camel rather than just focusing on Camel as some programming API or language. You can just run Camel, play around with it in your IDE, drag and drop messages around. If ever you get a bad message, a message goes through and something explodes, we'll just drag and drop that message from the endpoint into your file system, and use that as a test case. Make that a test case that you send the bad message in, and you should handle the bad message in a nice way. Like, you should do a validation step to pull out the bad message and send it to a bad messages queue or something. So you can gradually play with your system. When something's not working, keep playing with it and trying it out, tracing. If something's really bad, drag and drop the message back onto the file system. If I'm browsing a queue, let's go back to the queues again. If I go to the beer queue, we should have a pizza queue, right? I've got a beer queue. If I make a new directory called pizza, yeah, that's good. I've got a directory called pizza now. I can now just drag and drop. These are JMS messages on a real JMS message queue. I can just drag and drop them into a file system. The first time you do a drag and drop, this is a clean installation. The first time you do it, it says, this is the Eclipse thing. It says, oh, when you drag and drop, do you want to copy the files? You go, yeah, okay. Let's say, whenever I drag and drop, copy the files. If you say okay, it never asks you again. Okay, so it's copied the first one. Let me do the second one now. And it shouldn't ask. Oops. Let me drag and drop. Click, drag, drop. Yay! So it didn't ask the second time. So now we just have two files, which is just blobs of XML. You can look at the XML, and they're just a blob of XML with all the headers and the payload. So you can check these into source control. You've now got something you can use in your test case. You can drag and drop them again. You can send them in a test case if you wish. So it's really, really easy. So the Eclipse tooling makes it really, really simple. So you can just, a couple of clicks, you've got a project with Camel inside it, and you can run it. A couple of clicks, you've got it running. A couple of clicks, you can drag and drop messages on, and you can just play with this stuff. So really, if you're going to play around with Camel at all, I'd recommend install Fuse IDE first before you do anything else. Start a project, start playing with it, send some messages, have a little play, and then gradually explore different technologies, different endpoints, different patterns. But start with something really, really simple that just works, and then gradually grow in any direction you need to go. I think we should probably stop now, shouldn't we? Enough pizza, do you think? Yeah. Let's have a break. I'm here all evening. We can talk about anything whenever you like. So just to recap, we talked about Camel, given an overview. Fuse IDE, I've given a brief demo. I haven't shown you the visual designer, but that's kind of boring. You can play around with that yourself. You just drag and drop patterns on the camera, so it's like, yeah, whatever. But really all that does is okay, let me do a quick talk about that, and then we'll do pizza. Just for 2 minutes, I'll do a quick talk. Let's imagine you're creating a brand new Camel XML. Right-click, new Camel XML file. I can use Spring or OSGI Blueprint or Route, which is like a standalone XML format that works with CDI or no dependency injection. I'm going to call this pizza time to remind me to stop talking soon. We now get an empty canvas. I now have all these endpoints and routing steps and things like that. You can pin things and all that malarkey. So now I can do things like I can drag and drop an endpoint and drop it, and I'll drag and drop another endpoint and drop it. On the properties tab, if I click, I can edit q :foo, and I'll say file : bar. So I'm going to go from a queue to a file system. Here's how you do the connection. I hover. I'm not touching the keyboard, I'm hovering. I'm going to click. I've clicked, and I'm dragging. Notice the no entry sign because I can't connect to anything there. I can't connect to myself, but I can connect over here. It's back. Oh, I can't. Oh, yeah, I can't. No, right. Yeah. Okay, so we get an idea. And then you can drag and drop this thing around. That's kind of a bit laborious. So I tend to just prefer clicking, right click, do add, endpoint, click. And it adds the endpoint and connects it, and you've done. But if you like a drag and drop, knock yourself out. Do a drag and droppy. Very quickly, what the Camel tooling does is it does something called round tripping. So what this makes is a regular Camel XML file, right? A vanilla Camel XML file. There's no magical file somewhere in the file system with a diagram in it. Everything is just in the Camel XML file. This looks like a normal Camel XML file. If you have a Camel XML file in your project, you can open it with the editor and it visualizes it. And you can edit it and it saves it back. So there's no magic file somewhere else. We just use the regular Camel XML file. But we round trip, so I can type in some comments, and I can add a string bean, something class equals foo, com.foo. So I'll put a string bean in there, I've got a comment there, and I've got a comment here. Fuse IDE is cool too. And then I can add a comment in here. Just just about pizza time. Right, so let me change this to beer. Okay, and then if I go back to the diagram, click, the beer is updated in the diagram. Okay, so we've round-tripped, we've taken the edited source from the file system, we've updated the diagram. Now I can edit the diagram, and I'll do file and column pizza time now, and I can go back to the source code and see it's updated the XML, it's kept the comments, it's kept the bean, the spring stuff, it's kept comments in the back. One thing to notice though is the rule is anything inside the camel context is going to get trashed. Any comments are turned into a description element. The reason for that is the description element we can edit in the diagram, in the tool, in the Visual Designer. Yay, pizza! And I can go back to the source and it's updated. But one of the advantages of not using XML comments inside the camel context is that description metadata keeps in the runtime. So when you're running stuff, your descriptions are still there. So when your stuff is running in production, you can describe the endpoints and the routes and the steps and the context. And at runtime, we can visualize it in the runtime tooling. So don't use comments inside the camel context, they'll be trashed anyways. Use the description elements. But otherwise, we completely round trip and preserve everything else. Okay, so that's the designer. And we're done, I think it's pizza time. Question?
How do you save the position of the object in the design?
We redraw it every time.
Okay, so there's no point in moving around?
Yeah, I don't think we've done that anymore. We did used to, there is an XY in the Camel DSL, so we could save it. But we've realised it's just easiest to redraw it. So we just redraw it every time.
Okay, so there is no point in moving them?
No, not really. Not really. We did have it in there. We might put it back for a while because we purposely put a description element in Camel with an XY coordinate so we could store the XY. But we just never got around to using it. But we could put that back in if people really care. Oh, one other quick thing just before we eat pizza and drink beer is lots of customers and users I've talked to over the years, they'll do some Camel stuff and their boss comes along and says, so what have you been doing all these years? And you have to do like a presentation to your point-head boss and his teammates or whatever. Say, oh, here's what we've just done, and then you get the PowerPoint out, and then people go, oh, let me get the stencil for the enterprise integration patterns and all that kind of stuff. Just open your Camel XML and right-click, export diagram to JPEG or GIF, and click OK, and it makes a GIF that you can just add to your PowerPoint. So rather than having to draw a PowerPoint of your routes, just use Camel, the Eclipse plugin, to generate the picture. Just open your real code for Camel, generate a picture for it, and then put that in your PowerPoint. Okay. And then you're good to go. I will show you at some point after pizza or during the evening. We have a web version of this which is way cooler, really. And then you can just link to the picture, which is even kind of cooler. But pointy-head bosses like PowerPoint, so that's the PowerPoint option. But there's cooler web versions.